Hello everyone. So we'll discuss about types of SDD, syntax directed definition. So before learning types of SDD, first we'll recall what is a meaning of syntax directed definition. Syntax directed definition is a combination of context-free grammar and semantic rules. So we have two types of syntax directed definition. The first one is SAttributed SDD and the second one is L-attributed SDD. So in syntax directed translation, every non-terminal can get 0 or more attributes. So attributes are nothing but the data types, strings, numbers. These are all termed as an attributes. So syntax directed translation, in that every non-terminal can get 0 or more attributes. So now we'll see what is a meaning of S-attributed SDD and L-attributed SDD. So coming to first one, S-attributed syntax directed definition. An S-attributed syntax direct definition that uses only synthesized attributes. So S-attributed SDD uses only synthesized attributes. As we discussed previously, in attributes also we have two types of attributes: synthesized attribute and inherited attribute. So in S-directed SDD, it will use the synthesized attribute. For your easy remembrance, you can remember like S and S. That is, S-attributed uses synthesized attributes. And L-attribute, an SDD that uses both synthesized and inherited attributes, is called as L-attributed SDD. But each inherited attribute is restricted to inherit from parent or left sibling only. So L-attributed SDD is nothing but if it uses both synthesized and inherited attribute, then it is called as an L-attributed SDD. So what is the meaning of synthesized attribute? Synthesized attribute is nothing but if a node takes the values from its children, then it is called as a synthesized attribute. Whereas inherited attribute is nothing but if a node takes the values from its parent and siblings, then it is called as an inherited attributes. But here there is a restriction in inherited while using the inherited attribute, that is, it is restricted to inherit from parent or left sibling only. So when considering with the siblings, it should take the values only from the left sibling. Right sibling is not allowed. So example of S-attributed STD: A tends to B, C, D. Here A is the parent node and B, C and D are the children nodes. So A dot S is equal to B dot S, A dot S is equal to C dot S, A dot S is equal to D dot S. That means here the node is taking the values from its children. The parent node is taking the values from its children. Now let's check the example of L-attributed SDD. That is, A is equal to X, Y, Z. Here Y dot S is equal to A dot S. That is, the child is taking the value from its parent. And Y dot S is equal to X dot Z. So Y dot S is equal to X dot Z. So we should take only the value from the left sibling. So to the Y, the left sibling is X. So we cannot take as Z dot X. Y dot S is equal to Z dot S cannot be considered because Z is the right sibling for Y. So here we need to consider only the left sibling values. So here we have taken as Y dot S is equal to X dot S. Sorry, here it is written as Z, it is S. Clear? In L-attributed SDD, it uses both synthesized and inherited attribute. So we know clearly that in synthesized attribute, a node takes the values from its children. Whereas in inherited attribute, a node takes the values from its parent or siblings. But here, when using the inherited attributes, there is a restriction that it should inherit the values from its parent or only from the left sibling. And the next is SAttributed SDD. In this, the semantic actions are always placed at the right end of the production. It is also called as postfix syntax directed definition. So here the semantic actions always they are written in the flower braces. These semantic actions are always placed at the right end of the production. So this is also termed as postfix SDD, whereas in L-attributed SDD, semantic actions are placed anywhere in the right hand side production. So here A tends to, so here anywhere we can take either the starting of the right hand side production or in the middle of the right hand side production or at the end of the right hand side production. So the anywhere these semantic actions can be placed. So semantic actions are usually written in this flower braces. And the next one, in S attribute, the attributes are evaluated with bottom up parsing. So the attributes will be evaluated from bottom up parsing. Whereas in L attribute, attributes are evaluated by traversing parse tree depth first and left to right order. So here attributes are evaluated by using the depth first and then left to right. So these are the S attributed SDD and L attributed SDD. So here is an example for S attributed SDT. This is an syntax directed translation for simple desk calculator. So here we need to consider the production as well as the semantic rules. So here the production we have taken as L tends to E and E tends to E1 plus T, E tends to T, T tends to T1 star F, T tends to F, F tends to E and F tends to digit. So here this L tends to En is the augmented grammar, and the semantic rule for this is print E dot val. So I told you that semantic rules should always be written in flower braces. These semantic rules are nothing but the actions. Next, for the production E tends to E1 plus T, the semantic rules can be written as E dot val is equal to E1 dot val plus T dot val. In the same way, for all these we need to write. So E tends to T. So the semantic rule for this is E dot val is equal to T dot val. And T tends to T1 star F. T dot val is equal to T1 dot val star F dot val. T tends to F. T dot val is equal to F dot val. F tends to E. For this the semantic rule is F dot val is equal to E dot val. And the next production is F tends to digit. So here the semantic rule is F dot val is equal to digit dot lex dot val. So this we have written the production as well as the semantic rules for this. Now we will construct the tree according to this. So here L, the first production we have considered as the augmented grammar. So the root node is L. So we have started from L. L tends to En. So those values are taken. So here L is called as the determined state. Okay. So here we have taken this expression like 2 plus 4 into 5n. Here n is nothing but why we are using this is not mandatory to use. The value of this is stored in n. So we have considered the first production L tends to En, L tends to En. Now E tends to E1 plus T. And next is E tends to T. So E tends to T. And next T tends to T1 into F. So T tends to T1 into F. And next T tends to F. That is here T tends to F, T tends to F. And F tends to E. So F tends to E. And next, f tends to digit. So here f tends to digit, f tends to digit, f tends to digit. Now we have to write the semantic rules for these productions. So here we have taken like as we have discussed that SAttributed follows bottom up parsing. So from bottom we need to start. So for digit, the semantic rules are digit dot lex dot val. So digit dot lex dot val is from the given expression, the value is 2. So that is assigned to 2. So this is being passed to f dot value, that is been given to f. So the value is 2. So f is assigned to t. So the t dot val also becomes 2. And t value is assigned to e. This is nothing but from the productions only I am taking here. You can see here e tends to t, t tends to f. That means f value is assigned to t, t value is assigned to e. So t tends to e, e dot val is equal to the same value is been assigned here. And next here, so digit dot lex val is equal to the second one. So after plus we have the digit 4. So that is being assigned here. Digit dot lex val is equal to 4. So this digit value is assigned to f, that is f dot val is equal to 4. F value is assigned to t, t dot val is equal to 4. And then now here digit dot lex val is equal to the next operation. After star we have the digit as 5. So we have considered 5. So digit is assigned to f. So f dot val is equal to 5. Now 4 into 5. So 4 into 5 is, so 5 into 4, 5 into 4 is 20. So that value is assigned to t. Now this plus e value, e plus t. So e value is 2 and t value is 20. 2 plus 20, the value is, the answer is 22, that is assigned to e. Clear? So in this way we are going to draw this SAttributed SDD. And the next one is L-attributed SDD. So L-attributed SDD, we need to consider the production as well as the semantic rules. The productions are considered here as D tends to TL, T tends to int, T tends to real, L tends to L1, ID, L tends to ID. So the semantic rules for this production are L dot in is equal to T dot type, and t dot type is equal to integer. Here t tends to real is nothing but t dot type is equal to real, and L tends to L1 comma ID. Here the semantic rule for this is L1 dot in is equal to L dot in add type of ID dot entry comma L dot in. And for L tends to ID, the semantic rule is add type of ID dot entry comma L dot in. So now we should consider this. So here I am considering the expression like int id1, id2, id3. So based on this production, you need to consider you need to construct this. So first production is d tends to tl, d tends to tl, and t tends to int. So t tends to int. Next, L tends to L1 comma ID. So L tends to L comma ID. So here it is written as 2 times. L tends to L comma ID and L tends to ID. So now we need to write the semantic rules here. Okay. So now T dot type is equal to int. And here L dot in is equal to int. And L dot n is equal to int. So here we got our expression id1, id2 and id3. So this is our SAttributed and L-attributed.